Next, I want to explore function overloads, a feature that allows us to define multiple function signatures, so to say, for one and the same function, which simply means we can have multiple possible ways of calling a function with different parameters, for example, to then do something inside of that function. And a good example where function overloads can help us can be seen a little bit further above. This add function we wrote earlier. What it does is it takes two combinable values, which means strings or numbers, and then as you can see, the return type TypeScript infers here also is combinable. And this simply means TypeScript understands that what it returns also either is a string or a number. But actually, if you think about it, that's not really true. I mean, technically it's true, but we know that if we pass in two numbers, the return type will always be number. If we pass in at least one string, the return type will be string. Now, why might this matter? Keep in mind that the add function is written like this. Actually, we can comment out everything below and add some new code up there right below the function. If I now get my result here by calling add and I pass in 1 and 5, you see result is of type combinable. A consequence of this is that TypeScript does not know whether result is a number or a string. Now this might really matter if we are passing in strings. If I pass in Max Schwartz here, then this works, but I still get back combinable. Now as a consequence, I can't call string functions on result. I can't call split, for example, to split on the white space. I know that this will work because I know that when I call the function like this, I will make it into this if branch and I will get back a string. So I know that result will hold a string, but TypeScript just knows that it holds a string or a number. Now, of course, we can use typecasting here and tell TypeScript that what we get back is a string. We can do that with the typecasting syntax you learned about earlier. Still, it's not optimal that we have to do that, I would argue, because we have to write more code here, even though we would expect TypeScript to understand that when we call this function like this, we always get back a string. But TypeScript isn't really analyzing our code good enough here. And that's where a function overload can help us. A function overload is written by simply writing function right above your main function, so to say, with the same name. So you repeat this line here, basically. However, without the curly braces, no opening and closing curly braces thereafter. And now here, you want to use specific types, number, and then define a return type for when this is the case, when you get at least one number. And there we could say, then the return type is number. So now with that, we're saying to TypeScript, if we call this function and both arguments are a number, then this function returns a number. Now this, of course, is not syntax that would work in JavaScript. It will be eliminated by TypeScript in the compilation process. But TypeScript merges this function information and this function declaration here together and basically combines the knowledge of these two lines here. And now it knows, okay, we can call this function here either with a and b of type combinable or with a and b of type number. By the way, you also can add more or less parameters here in your overloads. You're really flexible there. We could also add function add here and just expect one number and return a number. And this would also work if we make b optional in our other overloads as well. Because ultimately, of course, you need to ensure that your code in here always works and you receive all the arguments you need in the end. So if b would be optional here, then you see this works. Now, of course, we just would have to work around b being potentially optional down there. I don't need that, however, so I'll get rid of that and just leave this. But I also now want an overload for when we call this with strings. So I will add another add function overload here, where a is a string and b is a string. And then I'm pretty clear regarding the fact that what we return will be a string. By the way, it is a good practice to add a semicolon after these overload lines here. So now with that, I'm saying if we're calling this function with two numbers, we always get back a number. If we call it with two strings, we always get back a string. If we call it with one string and one number, we technically also always get back a string, but I don't want to add all these possible combinations here. Of course, I could add more. and then also add number here, or the other combination we might have, which is this one. Well, I guess now I did add all combinations. And now I'm listing all potential combinations of values here and what we return in each case. Now with that, you see the error down there is gone, because now TypeScript knows that result will be of type string if we call add with these two values, which are both strings. And if I hover over add, you see there are 3 additional overloads available. Here I'm calling add with 2 strings, but TypeScript knows there are 3 other ways of calling this. For example, with a string and a number, in which case I get back a string, with a number and some string, or with 2 numbers. This would also work. Then, of course, I can't call split, because TypeScript correctly identifies that when I call this with 2 numbers, I get back a number, and on a number, you can't call split. So these are function overloads, and they can help you in situations like this here, where TypeScript would not be able to correctly infer the return type on its own. Here, you can be really clear about what's getting returned for the different combinations you might support in your function.